So that was finding the zeros. So now we're gonna look at working backwards. So let f be a polynomial function that has real coefficients. If a plus b, where b does not equal 0, is a 0 of the function, then the complex conjugate a minus bi is also a 0 of the function. So it says find the fourth degree polynomial function with real coefficients that has the given zeros, -1, 5, and 3 minus 2i. And so in the previous section, we did something similar to this. And so let's go ahead and do this example. So the first thing you want to do is go ahead and list your zeros here. So we have x equals -1, x equals 5, and x equals 3 minus 2i. They tell you that this is a fourth degree polynomial, so you should have 4 zeros listed. So the conjugate pair definition above over here tells us that if we have a complex number, then its conjugate, in this case 3 plus 2i, will also be a 0. Once you have your zeros listed, then we want to write down the factors. To get the factors, we take the -1 and move it to the left side. So to do that, I add +1 and +1. So that would be my factor. I would subtract 5 on both sides. Subtract the 3, add the 2i, subtract the 3, and subtract the 2i. So these are our factors. Once we do that, then we want to find a polynomial. So I'm going to call it f of x. And I don't know what the coefficient is, so I'm going to call it an. And then I'm going to list these factors. Okay, so then what we want to do is multiply out these factors. So I'm going to have an, so I'm going to multiply x times x is x squared, x times -5, -5x plus 1x minus 5. Simplify the parentheses. So we have x squared, -5x and x is -4x minus 5. And then we're going to multiply this out. X times x is x squared. X times -3 is -3x. X times -2i is -2ix. Then we start with a 3. -3 times x is -3x. -3 times -3 is +9. And -3 times -2i is +6i. And then last, we multiply 2i times x is 2ix. 2i times -3 is -6i. And 2i times -2i is -4i squared. So we want to simplify. So here we're going to have some things that are going to cross out. So I have an x squared. I'm going to write x squared. Then I have a -3x minus a 3x gives me a -6x. And then -2ix and +2ix will give me a 0. And then 6i and -6i give me a 0. And then I have negative 4i squared. Remember, your I squared, we can substitute it with a negative 1. So negative 4 times negative 1 is positive 4, plus a 9 would give me 13. So let me repeat that. So I squared gives me negative 1 times negative 4 is positive 4, plus the 9 gives me 13. So we keep multiplying out. X squared times x squared is x to the 4th. X squared times negative 6x is negative 6x cubed. X squared times 13 is positive 13x squared. Negative 4x times x squared is negative 4x cubed. Negative 4x times negative 6x is positive 24x squared. Negative 4x times 13 is negative 52x. And then negative 5 times x squared is negative 5x squared. Negative 5 times negative 6x is positive 30x. And negative 5 times 13 is negative 65. Gather your like terms. So we have 6x cubed and a negative 4x cubed. It's going to give me a negative 10x cubed. Then we have 13x squared plus 24x squared minus 5x squared. So 13 plus 24 is 37, minus 5 is 32. And then for the x, we have negative 52x plus 30. So that would be 22x. And then finally, for our constants, we have negative 65. So let's just double check our work. So we ended up with this here. X times x is x to the 4th. Negative 6x times x squared is negative 6x cubed. 13x squared minus 4x cubed plus 24x squared. 52x, negative 52x, negative 5x squared, and 30x, and negative 65. So gather like terms, x to the 4th, negative 6x cubed, minus a 4x cubed is negative 10x cubed. Then we have 13x squared plus 24x squared plus 5x squared. So that's 37 minus 5, 32x squared. And then our x's are negative 52 minus 30, 22x minus 65. Okay, so now that we have our polynomial of degree 4, we still don't know what this an is. And so that could be different possibilities, which we will, if it's not given to you other information, then we can leave it as a 1, or we just leave it as an. But in example 8, they are going to give us some more information. So they give us the zeros, but then they also give us this extra information. So for example, the zeros are x equals negative 3 and x equals I. we're looking for a third degree polynomial. We have a complex zero, so the conjugate, in this case would be negative I, is also going to be a 0. So my factors would be x plus 3, x minus I, and x plus I. So we would write down f of x is equal to x plus 3 times x minus I times x plus I. And so I forgot my coefficient. Let me go ahead and include it. And then I'm going to multiply x times x is x squared, x times I is xi, negative I times x is negative xi, negative I times I is negative I squared, or you can use the shortcut and square the coefficient here and the coefficient here. So we get x squared, this cancels. I squared can be replaced by negative 1 times a negative will become positive 1. Now we continue multiplying. X times x squared is x cubed. X times 1 is x. 3 times x squared is 3x squared. 3 times 1 is 3. Gather any like terms. Okay, and so this is where we stopped in the previous example. But now they give me this information, which means that when x is 1, our y is equal to 8. So since we have this information, then our y is 8 here. And my x, everywhere I see an x, I'm going to substitute a 1. And so by doing this, we're going to be looking for that leading coefficient. So we get an, 1 cubed is 1, 1 squared is 1 times 3 is 3, plus 1 is 4, plus 1 is 5, plus 3 is 8. So divide by 8. So that tells me that my leading coefficient is 1. So if I plug that back in, I get 1 times x cubed plus 3x squared plus x plus 3. Multiply the 1. And so that's just going to be x cubed plus 3x squared plus x plus 3. Okay, so example 9. So the answer for this is f of x is equal to 2x cubed minus 2x squared plus 50x minus 50. Okay, so if you would like to try this for extra credit, I'm going to give you 2 points on homework section 2.5 and 2 points on quiz. I believe it's 6, but it'll be the quiz that includes that section. So quiz with section 2.5. So show your work and submit it through email. Okay, example 10. Find the zeros of f of x given that 4i is a 0. So here they tell me that 4i is a 0. So that means that the conjugate is also a 0, negative 4i. Since 4i is a 0, then what I can do is I can use synthetic division. So my coefficients are 3, -2, 48, -32. Bring down the 3, 4i times 3 is 12i. -2 plus 12i, and then multiply that times 4. So 4i times 2 is -8i, and 4 times 12 is 48, times I is I squared. I squared can be replaced by a -1, so we get -48. So again, 4i times -2 plus 12i gives us -8i plus 48i squared. Replace I squared with a negative, and that's how we got this number over here. So now 4i, or -8i minus 48 plus 48 is just going to give me a -8i times 4. That gives me a -32i squared. I squared is negative, making that a positive 32 plus a -32, so that's going to give me 0. So we know that that is 0. So my quotient is going to be 3x squared plus -2 plus 12ix minus 8i. Okay, so these are your coefficients. So this is quadratic, but since I have these imaginary numbers, then I'm going to use synthetic division again with my second 0, -4i. So remember, the conjugate is also 0. So here, my coefficients would be 3, -2 plus 12i, and -8i. Bring down the 3 times -4i is -12i. So if I add -2 plus 12i plus -12i, the 12i's cancel, giving me a -2. -4 times -2 is positive 8i, so that gives me a 0. So since we were at x squared here, now this would just be 3x minus 2 equals 0. I can add a 2. So 3x is equal to 2. So my 0 will be x is 2/3 if we divide by 3. So my third 0 is 2/3. Okay, so you can still use synthetic division even if you have these imaginary numbers. Okay, so let's go to the next one. I'm going to go ahead and work out example 12. The answer for example 11 is x plus 5 minus 2 square root of 2 and x plus 5 plus 2 square root of 2. So you can try that, and then if you have questions, let me know. But example 12 is similar to example 11. So it says write as a product of linear factors, list all the zeros of the function. Okay, so here for this you can use the quadratic formula or you can try to factor. So for this one, we know that we're looking for the zeros. Since we're looking for the zeros, I'm going to go ahead and set it equal to 0. You can use P over Q and find the possible zeros and then find the synthetic division. You can go that route, but this is factorable. So x to the fourth would be x squared times x squared. And then for 9, I can use 9 and 1. Set each factor equal to 0 at the 1 on both sides. So x would be plus or minus 1 for my 0. Take the square root here. Subtract the 9. So x squared is equal to negative 9. Take the square root. So x is plus or minus 3i because we have a negative in the radical. So my zeros are x equals 1, x equals negative 1, x equals 3i, x equals negative 3i. So my factors will be x minus 1, x plus 1, x minus 3i, x plus 3i. So it says to write as a product of linear factors, so our answer would be f of x is x minus 1 times x plus 1 times x minus 3i times x plus 3i. Okay, and the last theorem here, the number of positive real zeros of f is either equal to the number of variations in sign of f of x or less than that number by an even integer. And the number of negative real zeros of f is either equal to and also even integer. So what does this mean? To find how many positive zeros we could have, then we count the variations of signs. So from here to here, it stayed positive. And then from here to here, it stayed positive. And from here to here, it stayed positive. So it never changed from positive to negative. So there was 0 variations. So what that means is that positive zeros is going to be 0. So there'll be 0 positive zeros for this polynomial. Now for the negative zeros, you want to replace x with a negative x. So here we get negative x cubed would be negative. Negative x squared would be positive. Minus x plus 8. And then we count the variation. So negative to positive, that's one change. Positive to negative, that's a second change. Negative to positive, that's a third change. So for my negative zeros, we have 3 sign variations. So that's going to tell me that we're going to have 3 negative zeros or 3 minus less than that number by an even integer. So 3 minus 2, 2 is an even integer, is 1. So we're either going to have, for the negative zeros, we're going to either have 3 or 1 negative 0. So since this degree is of degree 3, then your zeros could all be negative, or we could have 1 negative, and so the other 2 would be imaginary solutions, complex numbers, since we have 0 positive. Okay, example 14. A new bakery offers decorated sheet cake. So I'm going to make this an extra credit problem for exam 2, 5 points. Okay, and I'm going to go ahead and get it started for you, but basically you have a pan here that looks something like this. It's a rectangular solid, and the length of the cake to be 4 inches longer than the width, and the height of the cake to be 1/3 of the width. Okay, so the volume is given by length times width times height. And it wants to know what should the dimensions of the cake be. So the length, they tell us, will be the width plus 4 inches longer. And the height is, where's the height? The height of the cake is 1/3 of the width. So 1/3 of W. And then the width is W. Okay, so we can plug in this information here. And for L, W, and H. And then it wants us to, they give us the volume is 351. So here we have 351 is equal to our length, which is W plus 4, our width, which is W, and our height, which is 1/3 W. So essentially what you want to do is take this equation and solve for W. And so you're going to end up with a cubic function. And so then you want to use the possible rational zeros, maybe use synthetic division. And so what you'll be looking at is, for example, it would be like these problems here, where you have to find the actual zeros.